The conjunctive management paradigm sounds attractive, but how to put it into practice? What kinds of action or intervention are available and commonly embarked upon? This will briefly be outlined in this submodule. For that purpose, we will make a distinction between two levels of action. A. The level of area-wide planning, and B. Implementation of conjunctive water management at field level. Applying the conjunctive management approach in area-wide planning looks trivial and logical. Nevertheless, it often fails to be adopted, which causes its potential benefits to be foregone, and sometimes it may even lead to errors. The area-wide planning has to be rooted in adequate knowledge of the area's natural water systems. In particular, the hydraulic connectivities between groundwater and surface water need to be explored and analyzed carefully. The resulting knowledge will help avoiding double counting of available water resources, which is a not uncommon error in water planning projects. It helps also in detecting promising opportunities for conjunctive water management and in identifying hazards of harmful interaction between groundwater and surface water development. It cannot be overemphasized that sufficient information and knowledge on the local water systems are essential for optimal design and planning. Modern information systems and modeling tools are most helpful to convert information into a good understanding of the behavior of the water systems in the area concerned. Now, let us see how to deal in planning with overexploited aquifers. Overexploitation of aquifers is a widely experienced problem, especially in areas with a dry climate. Options for restoring a dynamic equilibrium in the aquifer are substantially widened by adopting a conjunctive management approach. The slide shows this in a systematic way. On the left-hand side, it shows an initial situation of intensive groundwater abstraction, causing a state of overexploitation in the aquifer concerned. Restoring equilibrium would require the excessive fraction of groundwater abstraction to be eliminated, but without losing sight of the fact that total water demands in the area still have to be met. In the slide's center, three options are shown for compensating such an intended elimination. Conceptually, these options include demand management, substitution by other water sources, and groundwater resource augmentation. At the right-hand side, the new, or final, situation is shown after restoring hydraulic equilibrium in the aquifer by applying the three mentioned options. Now we move to the implementation level. At the implementation level, three categories of interventions can be distinguished according to the direct objective pursued. A. Source selection. B. Resource augmentation. And C. Environmental control. Especially in the latter two categories, there is a diversity of activities and techniques. These include managed aquifer recharge, MAR, watershed management, water desalination and/or water recycling, water level control, restricting groundwater pumping, and wastewater management. Conjunctive use of surface water and groundwater is the most intuitive form of adopting the basic ideas behind conjunctive management. Its main goals are reducing the risk of water supply shortages, minimizing the cost of supplied water, and expanding profitable water use, for instance, by increasing the area under irrigation. Understanding the latter may require some explanation. This explanation is provided in the next slide. How options for expanding an irrigated area may be created by conjunctive use of surface water and groundwater is shown in the figure of this slide. Relevant features are the variability over time of irrigation water demands and of surface water availability, the capacity of irrigation canals that convey surface water, as well as the permanent availability of groundwater. It can be observed that the irrigated area according to curve 1, that's for the case that only surface water is used, is constrained by canal capacity in June and by river flow in December-January. Using additional groundwater, see curve number 2, relaxes these constraints during the most critical periods of the growing season and thus enables the irrigated area to be increased. You may note that the additional irrigation water applied is not only supplied by groundwater during the critical periods, but also by more intensively used surface water during other parts of the year. Topographically flat areas with shallow water table often suffer periodically from excessive water near or at the land surface. We call this waterlogging. Drainage systems based on ditches or tile drains provide the classical solution of water level control. Note that these systems make use of the interaction between groundwater and surface water. Control of surface water levels is effectively producing control of groundwater levels. The drainage infrastructure can also be used for other purposes than getting rid of excessive water. Purposes like the removal of excessively mineralized water and groundwater level recovery during or after relatively dry periods. Polders are areas where the water levels are purposely controlled by human action. This slide shows components of the technical infrastructure for water management in polders: drains, ditches, canals, and a pumping station. These infrastructural elements are coupled. It is perfectly clear that groundwater and surface water systems here are interconnected. which demonstrates that water level control in polders is a form of conjunctive water management. Springs, base flows of streams, and oases in climatically dry regions do exist thanks to groundwater systems with locally shallow groundwater levels. Intensive groundwater pumping produces declines of these groundwater levels. This often leads to a reduction or complete loss of spring flows and base flows, and to the shrinking or disappearance of oases. Conjunctive management of groundwater and surface water has several potential benefits. They are outlined in the table of this slide. In summary, they include 1. More fresh water is becoming available for human uses at lowest cost and wider access to people. 2. Reduced water shortages risk and enhanced water resources sustainability. 3. Improved basis for water-related environmental control. And 4. Optimal approach to water resources planning. In the next submodule 4.3, we will take a closer look at one of the most promising conjunctive management strategies, managed aquifer recharge, MAR, and get an impression of the different types of benefits produced in a number of real-world cases.